In this class, we are going to learn about the three-noded bar element. In one of the previous lectures, we learned about the two-noded element, which looked like this. So we had two nodes, 1 and 2. At the extreme left, the zeta coordinate was -1, at the center zeta was 0, and extreme right, the coordinate was zeta equals to +1. Now, in case of three nodes, we will have node 1, node 2, and there is another node at the center. Now in the two-noded element, we had q1, which was the displacement at node 1, given as alpha 1 plus alpha 2 zeta 1, and q2 was, this was zeta at 1, alpha 1 plus alpha 2 zeta at 2. So same way, here it will be alpha 1 plus alpha 2 zeta at 1 plus alpha 3 zeta square at 1. There is an additional term here, alpha 3. Writing this in the matrix form, we get, on the left hand side we have q1, q2 and q3. Alpha 1, alpha 2, alpha 3 are the common terms in all the three equations. Zeta square at 1, 1, zeta at 2, zeta square at 2, zeta at 3, zeta square at 3. Substituting the values of zeta at 1, zeta at 2 and zeta at 3 in this equation, we get this matrix 1, -1, 1, 0, 0, alpha 1, alpha 2 and alpha 3. We need alpha 1, alpha 2, alpha 3. So this matrix becomes inverse . So let us call this matrix as A, and we need to find out the inverse of matrix A. First we need to find out the determinant. So the determinant of A is equal to this term 1 into 0 minus 1 into 0 minus this term, so minus of -1 into 1 into 0 minus 1 plus 1 into 1 into 0 minus 1. we get an answer of -2. Next, we need to find out the cofactor of A. So to find out the cofactor of the first term, let us write down the signs first. Plus minus, plus minus, plus minus, plus minus, plus. So to find out the cofactor of this first term 1, okay, we need to multiply this 4. Okay, so when we cross multiply this, we get 0. So I'll write down here 0. Next, we have to find out of this term -1. So I'll have to multiply this and this. So 1 into 0 minus 1 into 1. Which is -1. Next, I need to find out of this term. So I've got to multiply these 4 terms and I will get a -1. So 1 into 0 minus 1 into 1. So -1. Okay, so this procedure continues and this is the answer if I rewrite this, I get 0 0 -2 1 -1 0 -1 -1 2. Next, we need to find out the transpose of this matrix. -1 -1 2. This is cofactor of A, the transpose of cofactor of A. So A inverse is -1/2, that is 1 upon the determinant, into this matrix which we have just obtained. -1 -1 2. We can now write alpha 1 alpha 2 alpha 3 equals to -1/2 0 1 -1 0 -1 -1 -2 0 2 into q1 q2 q3. This equation, the first equation that we started with, this set of equations could also be represented as q1 q2 q3 if I say denote it as q equals to 1 zeta square into alpha 1 alpha 2 alpha 3. This could be written as. So now substituting in that the value of alpha 1 alpha 2 alpha 3, okay, we could also say that q equals to n into alpha. Let us substitute the value of alpha 1, alpha 2, alpha 3 in the equation we wrote. So it is 1 zeta, zeta square, and alpha 1, alpha 2 is minus half into this bracket matrix into q1, q2, q3. This is a 1 by 3 matrix and this is a 3 by 3 matrix. So when we multiply this 2, we should get 1 row and 3 columns. So let us multiply this and see what we get. So we get zeta minus zeta square minus zeta square and minus 2 plus 2 zeta square into q1, q2, q3. So taking this half term inside, or we could also say, if we remove the zeta term common out, here this would be 1 plus zeta. Similarly, this here would be one minus zeta, and this would be 1 minus zeta square. This becomes, so 1 minus zeta square is 1 minus zeta into 1 plus zeta. So it becomes like this, 1 minus zeta square, which is nothing but of the form a square minus b square, which can be written as a minus b into a plus b. q1, q2, q3. In this equation, this term is n1, this is n2, and this is the shape function n3. So rewriting, n1 equals to minus half zeta into 1 minus zeta, n2 equals to half zeta into 1 plus zeta, and n3 equals to 1 plus zeta into 1 minus zeta. We will continue with the variation of n1, n2 and n3 in the next video. Thank you.